All right, so we're back, and we just finished saying that dilations have create a similar figure, not a congruent figure, and there is no change in direction on those shapes once they're actually transformed. So I need you to stick with me, Juan Carlos. I hope you're paying attention. David, make sure you're paying attention. Let's see, Adam, Mark, who else? Gosh, who else do I need to tell to remind to pay attention? Let me see. How about some people who are always paying attention? Allison, and let's see, Jessica. I hope your head's up and not down. So let's finish up this real quick. Last one. We're on this one. Anybody think of what we've done? We've done dilation, translation. What's the last one? Reflection. Reflection, I think, is probably the easiest one. And it's the mirror image, right? This is when we do a mirror. I hope I spell it right. I know I did. Mirror image. So we do a reflection. Think of a mirror. All right. So if we think of a mirror and we're going to reflect there, in this case, we don't really have to think much about the algebraic rule because there's two rules. Either you're going to reflect over the x, so you're going to over the x-axis, over the x-axis, so that means here's a little graph, here's your x-axis, and if you have an arrow pointing up and you reflect over your x-axis, where's the arrow going to go? Your arrow is going to be pointing down. So if this is A, this would be A prime because it went from over the x-axis. So if you're doing over the x-axis, then you have one rule to follow, and that's it. If you notice that it started with the positive y's, and then by the time it was finished, it ended with the negative y's, and that's exactly what's going to happen. So the rule is xy, the original point, is going to change, but whatever they tell you, if they want it over the x, you leave the x alone, and you change the opposite one. So that means you're going to do the opposite to the y. The negative means opposite. That means you're going to multiply by a -1, which changes everything to the opposite. Basically, change the sign. Now, if you're going to reflect over the y-axis, then it's going to look like this. So if you have an arrow pointing up, and that is your A, and you reflect it over your y-axis, what would happen? I guess I should have drawn a left arrow. That would make more sense. But if I reflect over the y-axis, this is actually going to change. This point is now going to become, this point right here is now this point right here because it's flipped. It's like picking it up and over. So I apologize that I used such a horrible shape. Actually, you know what? Let's do this. I'm going to do one on the bottom. Let's cancel that one out. I'm going to do this. If I take this arrow that's pointing to the left and I reflect it over the y-axis, it is now going to switch directions. So now it's going to be facing that direction. So if this is A, this is A prime, and you can tell now that there was a direction change. So here, this would be, the original would be XY. And what do you think, what do you suppose is going to happen to these guys over here on this side? In this case, we kept the Y values the same, but here we started on the left and we ended up on the right. So you're going to do the correct opposite to the X and keep the Y the same. Not much to do with this one. This one is pretty straightforward. So on this side over here, we're going to go back over here. And we're not going to do both because they're, well, we might be able to do both. If we reflect this one over, if we take this A, B, C, D and we reflect it over the Y, and if you're not sure how to do it, you count the boxes. D is one box away from the y-axis, so it should be one box away from the y-axis on this side. This should be 1, 2, 3, 4 boxes away. 1, 2, 3, 4 boxes away. This one should be 3, 1, 2, 3. And then this one should be 3, 4, 5, 6. So 3, 4, 5, 6. And then the last one should come straight down and it's on the same level as the D. So at that point, you can connect your pieces and you can see that it is a reflection. And I guess I got to go this way and this way and this way. So now this is, where would you see this is D prime? D prime reflected. D prime, this is E prime. This is A prime. Oh, I'm all confused. B prime, and this one would be C prime. So you can see the reflection, and that one was over the y-axis. And I'm just going to do 1 point real quick so that you can see. C right here was negative 4, 3. So at C, it's negative 4, 3. And if you do C over here, C now is 4, 3. See how only the x changed and that was reflected over the y-axis, I'm sorry. Perfect. So we're done with reflections. So this is what you need to know about reflections, because tomorrow when you do a quizzes, it's going to be about reflections, dilations, and translations. So before we move on to this one, are the shapes still congruent? Did the size change? Did the shape change? No. So we know that these are congruent shapes or figures. And did the directions change? We know that the direction changed. We know that the direction changed. And that's all we're doing on this page. So I apologize, it's taking a little bit longer than I thought, but we need to remember this. These are the new things. So if you'll go ahead and flip your page down, and the last thing we talked about was 3 words: preserves congruence and or orientation. So preserves congruence. Congruence is basically that it stays the same, that it's congruent, that the size did not change. So when we're looking for congruence, same size, same shape. So same size and shape. Nothing changed, just the location. And orientation is direction. Orientation is direction. So we're looking for the transformations that preserve, that maintain, that keep is another word for preserve, that keep congruence and keep direction, keep orientation. So real quick, we're going to make a little chart up here. And it's super easy if you can remember just what those words mean. So we're going to do here translation. And I should have left more room. Translation, reflection, dilation, and we did not talk about this one, but we will later. So this one is rotation. That one's a little bit more confusing, so we didn't do that one yet. So we're going to talk about, I'm going to put here congruence and orientation. And we're just going to make a little table. We're going to just put a check marks over which one we feel maintains congruence. Translation. Translation. Did the size or the shape change? Let's go back to what we saw over here. Translation. When we saw the very first one at the top, we wrote down that the shapes are congruent and there was no direction change. So then over here, shapes were congruent, yes, and did the direction change? Did it maintain? Did it keep its direction? And yes, it did. So this was a yes. It does keep, preserve, maintain, keeps congruence and orientation. Oops, sorry. Yes, it keeps congruence, and yes, it keeps orientation. So let's talk about reflection. We just did that on the bottom, and you can actually see it right here. Let me see if I can zoom out just a little bit. You can see what we wrote without me having to flip over. And let me zoom into this real quick. So this is what you should see. Reflection, does it maintain congruence? Did the size or the shape change? No, so yes, it did maintain congruence. So yes, it's a congruent figure after a reflection. And did the direction change? It does have a direction change. So no, it does not maintain. It does not maintain or keep the same direction. No. And we're going to put direction change. No, it has a direction change. So it did not keep the same direction as the original is what it's saying. Dilation, let's go up to dilation. So let's flip this over and we can see it right here. Dilation. Dilations create similar figures, not congruent. So it did not keep it congruent. It made